Hi, here's a video that demonstrates how Device Authority's Keyscaler platform can be used to provision EAP-TLS certificates to Azure Sphere devices. As new out-of-the-box IoT devices proliferate in today's corporate networks, they are not equipped to connect to the enterprise network with the Bootstrap certificate they are provided with at manufacture, as Bootstrap certificates do not support the EAP-TLS protocol. What we don't want to have is the same password embedded on all these devices joining the corporate network, because if this becomes public knowledge, that's a problem, because devices will then be sharing credentials and you don't really know who they are on the network. With the introduction of Azure Sphere devices by Microsoft, these devices can now connect to a locked-down Bootstrap network in the production environment and fetch a Bootstrap certificate from Azure Sphere's security services. Azure Sphere brings together the best of Microsoft expertise in cloud, software, and silicon to provide the security foundation and connectivity to create intelligent, secure products and accelerate the IoT adoption at scale. The solution here is to get a certificate on the device that allows it to join the network using EAP-TLS protocol, so we can individually identify each device. Device Authority's Keyscaler platform has the ability to leverage this initial security foundation by enabling Sphere devices to connect to it and provide them with the operational certificates to automate and secure device enrollment to EAP-TLS-enabled enterprise networks. Let's take a look at the flow overview of how we can provision these certificates to Azure Sphere devices. Step 1 is to configure Keyscaler to establish the trust between the Keyscaler tenant and the Azure Sphere security service. We need to import the Sphere tenant certificate authority into the Keyscaler system. This is a one-time configuration. This will effectively allow Keyscaler to trust the Azure Sphere device when it tries to authenticate itself. Once the trust is established and the certificate policy and provisioning is in place, we can switch on the device itself. The first thing after boot up is that it connects to the Bootstrap network and connects to the Azure Sphere service to get its short-life Bootstrap certificate. This certificate is signed by the same Azure tenant CA whose public key was imported into Keyscaler. Once the device has the Bootstrap certificate, it can now, shown in step 3, do the initial registration with Keyscaler. This is done using REST APIs to do a mutual TLS authentication by presenting that Azure Sphere Bootstrap certificate. Keyscaler is now starting the certificate provisioning process based on the policies configured for the Sphere device. Internally, Keyscaler is generating the certificate and associated CSR, that's the certificate signing request, on behalf of the device and passing that CSR to the configured CA for signing as shown in step 4. Now the signed certificate still resides in Keyscaler, ready for the device to periodically check into Keyscaler and consume any assets, in this case the certificate, that has been issued, and effectively ready for download. Once the Sphere device has the signed EAP-TLS certificate, it will store the private key in the onboard secure key store and then use the certificate to connect and authenticate to the enterprise network, instead of using the pre-shared key or symmetric key that might have been hard-coded into the software and potentially shared among several devices. Apart from step 1 above, all the above steps are fully automated. It takes place without any human intervention. Here is an outline of what we'll show you in the live demo. First, we configure Keyscaler with the certificate policies and importing the Azure Sphere tenant CA. Next, we set up and configure the Sphere device with a Bootstrap certificate. Next, we register Sphere device using the Bootstrap certificate. And finally, provision the Sphere device with an EAP-TLS certificate. And now for the live demo. Once we have logged into our Azure account using the Azure Sphere CLI terminal, we can download the Sphere tenant CA from the Azure Sphere security services. Once downloaded, we can take a look at this certificate using an app like Keystore Explorer. Here we can see from the CN that this certificate has been issued for our tenant, and it has been issued by Microsoft Corporation Azure Security Services. This is the certificate that we will import into the Keyscaler system later in the demo. Next, we are going to recover the device. What this does is put the device back to factory settings. What we see here is that it's downloading a fresh bootloader and then flashed the device with that new bootloader and set it back to factory default. We do this to demonstrate that we are using a fresh out-of-the-box device. Once it has finished polling the image and writing to the device, it will reboot and output the device ID to screen as shown here. Now the device is fully recovered. We can check this by showing its Wi-Fi status and listing its certificates. You can see here there are no certificates on the device. Next, we log into the Keyscaler platform to configure it. First, we navigate to Manage X509 Certificate Registration. Here, we need to import the Sphere tenant certificate we downloaded earlier. We can see a pre-configured one called James Sphere CA and the public key of that tenant CA entered. This is tied to a certificate policy called Demo Policy. We'll take a look at that shortly. Next, we configure the certificate authority. For this demo, we are just going to use Keyscaler as the CA, but as mentioned before in step 4 of the overview flow, this could be done externally with any third-party CA or even enterprise ADCS services. You can see here typical CA setup. And finally, we can configure the device certificate policy. Here we have a pre-configured policy called Demo Policy. As we can see, the policy has a name, a description, and it points to the CA that we've already configured. The CN template is based on the device name. This will be the long UUID, unique device ID, provided by Azure Sphere Security Services. The certificate will have a validity of 1 year, and we could also rotate the certificate too. In this demo, we have disabled the Generate Cert and Key Pair on Device. Currently, Sphere devices can't actually generate keys in their secure store. They can only be imported. So in this demo, we'll keep this option disabled. And the Keyscaler server will generate the key pair, create the CSR, and submit that to the CA to get it signed, and then send the signed cert back to the Sphere device. We don't need to specify any directory, as Sphere is not running any agent software. When it receives the certificate, it will put it in the secure key store of the device. In this policy, we can revoke the certificate and apply the policy to a group called James Test. And finally, if we now navigate to our managed devices, we can take a look at the current list of devices that are registered. We can see our Sphere device is not registered at the moment. We'll come back to this later. The next step is to enable the device for development via the Azure CLI. This enables us to load an application from Microsoft Visual Studio into the Sphere device. When we type in the command, it will download the config files, flash it to the device, and reboot it again. Once it has rebooted, it will load the debugger, and then we will see it is successfully set up for application development. Also, the long device UUID is printed out. We are all now set up to run the application from Visual Studio. When we click the Run button, what we will first see is the connection to the device and then the application being uploaded. Then, when we see the code running, we can see that it's going to start connecting to the Bootstrap network. Next, the device will access the certificate store and show that there is about 24.5 kilobytes of space and that there are no certificates installed on the device. It then checks to see if it's connected to the Bootstrap network. Once the Wi-Fi is ready, as shown, it is ready to register. The device registers with Keyscaler using the Register API. It uses the certificate provided by Azure Sphere to perform that initial trust with Keyscaler. So we can see here that the URL it hits is the Service Access Controller X509, and also we can see that the HTTP code coming back is 200. If we take a look on the Keyscaler control panel, we can see the registered devices. Here we can see that our device is now successfully registered with Keyscaler, showing the long UUID for our device. If we then continue running the code, the device will now authenticate with Keyscaler and fetch the certificate. Here we can see the auth URL that was sent to authenticate, and again return an HTTP code of 200, which shows a successful authentication. We can also see here that Keyscaler has now provisioned the certificate to the Sphere device. The output window here shows the certificates that were sent back in the response and successfully installed in the device key store. Finally, we again press continue. We can now see the output of the certificate in the store. Now taking a bit of space. It has the identifier Keyscaler client. The CN is the long UUID allocated to this Sphere device. The certificate issuer, this is the CA we created in Keyscaler, and the certificate validity period. This certificate can now be used to operationalize the device by allowing it to connect to an enterprise network over EAP TLS protocol. Here is a recap of what we've seen. We configured Keyscaler and imported the Azure Sphere tenant CA to establish mutual trust. We put the Sphere device back to factory settings so it could connect to the Bootstrap network and fetch the Bootstrap certificate. We showed the registration of the Sphere device to Keyscaler and provisioned it with an EAP TLS certificate. Here's a summary of the key benefits of Azure Sphere integration we have shown. It provides automated PKI certificate solution for Azure Sphere devices and accelerates time to deployment. It reduces development time through easily consumable standard APIs. You get increased security of device identities through policy-driven credential rotation, and it provides a completeness of offering in line with evolving standards and legislation like FIDO and SDO. And finally, it increases network security posture by removing use of hard-coded pre-shared keys for connecting to enterprise networks. Thank you for watching. If you'd like more information, please do get in touch.